Let's know about parabola. When you kick a football or throw a ball in the air as it arcs up into the air and comes down again. Here in this picture you can see the formation of parabola by throwing ball. Here you can see equal distances between focus and directrix on the parabola. A parabola is a curve where any point is at equal distance from a fixed point is focus and a fixed straight line is directrix. Also, one amazing parabolic property is that any ray parallel to the axis of symmetry gets reflected off the surface straight to the focus. That explains why that dot is called the focus and because where all those rays get focused. So the parabola can be used for satellite dishes, radar dishes and so on. Geometrical interpretations of parabola. A parabola is the set of all points in a plane that are equidistant from a fixed line and a fixed point in the plane. The fixed line is called the directrix of the parabola and the fixed point is called the focus. Para means for and bola means throwing. That is the shape previously described when you throw a ball in the air. We also get a parabola when we slice through a cone. That is, a slice must be parallel to the side of the cone. Look at this. So the parabola is a section of a cone. Let us see geometrical representation of parabola is like this. Here the fixed point is called focus. Here this point is vertex in which the point of intersection of parabola with the axis is called the vertex of the parabola. Here the fixed line is the directrix of the parabola. Here it is the axis, in which a line passing through the focus and perpendicular to the directrix is called the axis of the parabola. Standard equations of parabola. The equation of a parabola is simple. We will derive the equation for the parabola whose axis of symmetry is along the x-axis in which the parabola opens to right side. That is the focus f of a and 0. Where a is greater than 0 means a is positive. Let f be the focus of the parabola and L be the directrix of the parabola. Let Fm be perpendicular to the directrix and bisect Fm at the point O. Let us take O as the origin. Draw MO to the axis x. X-axis is perpendicular to the y-axis. Let P of xy be any point on the parabola such that PF equals to the PB. Once again we write it as let P of xy be any point on the parabola such that PF equals to the PB. Mark this equation as 1, where PB is perpendicular to the directrix L. The coordinates of B are minus a and y. The equation of the directrix is x plus a equals to 0. That is, x is equal to minus a. By the distance formula, here we know that distance between any two points are d is equal to the square root of x2 minus x1 whole square plus y2 minus y1 whole square. Using this formula, we have the distance between the points P and F is equal to square root of x minus a whole square plus y square. And similarly, distance between the points P and B is equal to square root of x plus a whole square. Since PF is equal to PB, then we have square root of x minus a whole square plus y square is equal to the square root of x plus a whole square. Next, squaring on both sides of this equation, we get x minus a whole square plus y square is equal to x plus a whole square. To simplify this equation, we use identities of algebraic expressions such as a plus b whole square and a minus b whole square. Then we get equation as x square plus a square minus 2xa plus y square is equal to x square plus a square plus 2xa. Here in this equation, either sides of x square and a square terms will be cancelled out. Then we get y square is equal to 2xa plus 2xa. This implies y square is equal to 4ax. Hence, any point on the parabola satisfies y square is equal to 4ax, and mark this equation as 2. Conversely, let P of xy satisfy the equation number 2. Once again we take PF is equal to square root of x minus a whole square plus y square. Here we substitute the value of y square as 4ax. This implies square root of x minus a whole square plus 4ax. Then this is equal to square root of x square plus a square minus 2ax plus 4ax. This implies square root of x square plus a square plus 2ax. This is equal to square root of x plus a whole square. This shows that PF is equal to PB. Mark this equation as number 3. and so that the point P of xy lies on the parabola. Finally, we have proved from the equations 2 and 3 that the equation to the parabola with the vertex at the origin, focus at the point A, 0 and directrix x is equal to minus a is y square equals to 4a, x. We concluded from the standard equation of parabola that parabola is symmetric with respect to the axis of the parabola. If the equation has a y-square term, then the axis of symmetry is along the x-axis and the parabola opens to the right if the coefficient of x is positive. Look at this figure. You can see the y-axis and x-axis to the parabola. Directrix is parallel to the coordinate axis, origin O at the vertex of the parabola and focus of parabola through the axis of symmetry along the x-axis. Similarly, when the axis of symmetry is along the x-axis, the parabola opens to the left if the coefficient of x is negative. Here in this figure, observe that directrix is parallel to the coordinate axis and focus of the parabola through the axis of symmetry along the x-axis. Also origin O at the vertex of the parabola. If the equation of parabola has an x-square term, then the axis of symmetry is along the y-axis. When the axis of symmetry is along the y-axis, the parabola opens upwards if the coefficient of y is positive. Look this figure. You can see origin O at the vertex of parabola, focus on the parabola and the coordinates axis. Similarly, parabola opens downwards if the coefficient of y is negative. Here also you can see origin O at the vertex of parabola, coordinates axis and focus of the parabola on the axis of symmetry. In the conic section, latus rectum of parabola is the chord that is line segment perpendicular to the axis of the parabola passing through the focus and whose endpoints lie on the parabola. Look at this parabolic figure. You can see coordinate axis, origin at the vertex of the parabola and line segment perpendicular to the axis of parabola passing through focus and whose endpoints lie on the parabola is latus rectum. Next, to find the length of the latus rectum of the parabola, y square is equal to 4a, x here according to the definition of the parabola. Here in this figure you can see coordinate axis, origin O at the vertex, latus rectum passing through the focus f of a, 0 and line AC is perpendicular to the directrix of the parabola. Then the AF is equal to AC. But here AC is equal to the FM, which is equal to 2a. Hence AF is equal to 2a since the parabola is symmetric with respect to the x-axis. That is, AF is equal to FB, and so that AB is the length of the latus rectum, which is equal to 4a. Next, let's solve problems related to parabola. Find the coordinates of the focus, axis, the equation of the directrix and latus rectum of the parabola. Y square is equal to 12x. The given equation involves y square, so the axis of symmetry is along the x-axis. The coefficients of x is positive so that the parabola opens to the right. Then we compare the equation of parabola with given equation. Substitute y square as 12x, that is 12x is equal to 4a, x cancelling x term on both sides of the equation, we get a is equal to 12 by 4. Therefore a is equal to 3. Thus the focus of the parabola is 3, 0. Then the equation of the directrix of the parabola is x is equal to minus 3. And the length of the latus rectum is 4a is equal to 12. Now see the geometrical representation of solution to this parabola equation. Next, solve y square is equal to minus 8x. Here the given equation involves y square term, so the axis of the symmetry is along the x-axis. Then the coefficient of x is negative so that the parabola opens to the left side. Hence we take y square is equal to minus 4a, x here substitute for y square as minus 8x, which is equal to minus 4a, x here either side of the equation minus and x will be cancelled out. Next a is equal to the 8 by 4, in which 4 into 2 is 8. This implies that a is equal to 2. Thus the focus of the parabola is minus 2, 0. Then the equation of the directrix of the parabola is x is equal to plus 2. Finally, the length of the latus rectum is 4a, which is equal to 8. Now let's see the geometrical representation of parabola for the given equation y square equals to minus 8x. Next, solve for x square is equal to 6y. The given equation has x square term, so the axis of the symmetry is along the y-axis. Then the coefficient of y is positive, so that parabola opens to the upward. Here equation for this parabola is x square is equal to 4a, y, and substitute 6y for x square, which is then equal to 4a, y. Here either side of y will be cancelled out. This implies that a equals to 6 by 4, and after simplification we get a is equal to 3 by 2. Thus, the focus of the parabola is 0, 3 by 2. The equation of the directrix of parabola is y is equal to minus 3 by 2. Lastly, length of the lattice rectum is 4a, which is equal to 6. Now geometrical representation for the equation x square equals to 6y is like this, having origin no at the vertex of parabola and focus 0, 3 by 2. Next, solve for x square is equal to minus 16y. The given equation has x square term, so the axis of the symmetry is along the y-axis. Then the coefficient of y is negative, so that parabola opens to the downward. Here equation for this parabola is x square is equal to minus 4a, y, and substitute minus 16y for x square, which is then equal to minus 4a, y. Here either side of minus and y will be cancelled out. This implies that a equals to 16 by 4, and after simplification we get a is equal to 4. Thus, the focus of the parabola is 0, minus 4. The equation of the directrix of parabola is y is equal to plus 4. Lastly, length of the lattice rectum is 4a, which is equal to 16. Now geometrical representation for the equation x square equals to 6y is like this, having origin no at the vertex of parabola and focus 0, minus 4. Next, find the equation of the parabola with focus 6, 0, and directrix x is equal to minus 6. Since the focus 6, 0 lies on the x-axis and the x-axis itself is the axis of the parabola, hence the equation of the parabola is of the form either y square equals to 4a, x, or y square equals to minus 4a, x, since the given directrix x is equal to minus 6. So that a is equal to 6. Then the substitute a as 6 in the above equation, then we get y square is equal to 24x. Hence, here coefficient of x is positive, so that parabola opens to the right side when the axis of symmetry is along the x-axis. Next, find the equation of the parabola with the focus 0, minus 3, and the directrix y is equal to 3. Since the given focus is 0, minus 3, which lies on the y-axis, hence the equation of the parabola is of the form either x square is equal to 4a, y, or x square is equal to minus 4a, y, and since the given directrix is y is equal to 3, thus a is equal to 3, so that x square is equal to minus 12y. Here the coefficient of y is negative. Therefore, axis of the symmetry is along the y-axis, so parabola opens to the downward. Next, we solve to find the equation of the parabola with vertex 0, 0, which symmetric about the y-axis and passes through the point 5, 2. Since the parabola is symmetric about the y-axis and has its vertex at the origin, the equation is of the form either it may be x square is equal to 4a, y, or x square is equal to minus 4a, y, but the parabola passes through 5, 2, which lies in the first quadrant, and it must be open upward. Thus the equation is of the form x square equals to 4a, y, since the parabola passes through 5, 2, then we have 5 square equals to 4a into 2, which implies 25 is equal to 8a. Then we get a value as 25 by 8. Here we use to find out equation of the parabola by x square equals to 4a, y, which is then equal to 4 into 25y by 8. This implies that 2x square is equal to 25y, and finally, we get x square is equal to 25y by 2. Thank you for watching this video. If you like this video, then please do subscribe my channel. More videos related to mathematics topics.